This meeting is being recorded.
Good evening all to this 2 hours masterclass and course launch on functional safety for railways and metro.
Yeah, good evening. Thank you.
The objective of this webinar is to, Railway Academy regularly conducts a webinar series to build knowledge on emerging technologies with in-depth technical knowledge imparted by various experts who are with us. So our experts will be explaining the functional safety aspects in detail, but briefly, I would like to introduce functional safety as an imperative. It is imperative in today's industry to understand the requirements and applications of various standards to ensure safety and ensure that safety risks due to hazards are reduced to an acceptable value. And this is what is the prime theme of this webinar. So moving forward, I would like to introduce our master trainers for today. So today's session is divided across 4 mini sessions of 25 minutes each. So we have allocated 100 minutes on with our trainers. So I would like to introduce our first trainer, Mr. Dr. P. Rajagan. Just a moment, sir. I think I would request people to mute their microphones, please. Okay, so our first master trainer is Dr. P. Rajagondan. He has served as former general manager Indian Railways, and he's an expert in railway signaling, train controls, and telecommunications with more than 35 plus years of experience. Our next master trainer is Mr. Surendra Nath. He's expert in Senelec-based development, MISRA standards, Senelec and IEEE standards, and safety life cycles. Our third trainer is Dr. Ajit Pandey, whose core competencies lies in safety engineering, reliability engineering, and system assurance. Our fourth trainer is Mr. Rajesh Patel, who comes with expertise in design and development of RAMs and safety documents with application across EN standards. And he also has experience in design and development of system assurance design documents. So all these master trainers will take you through various aspects of functional safety today to help you understand the nuances of this emerging area, which can help you plan the growth of your career. So this is the prime objective that we have towards organizing this webinar. So through what all topics we'll be covering in next 100 minutes. So we'll start with introduction to functional safety, then study of EN 50126, specifications and demonstrations of RAMs, then study of EN 50129, software for railway control and protection systems, followed by study of EN 50159, safety related components in transmission systems. And towards the last part, we'll talk about study of EMI, EMC, and functional safety. So I would like to invite our first master trainer. So before inviting my first master trainer, there are a few important points I would like to share about this to make this session enjoyable for everybody. So I have a few requests. So first request is kindly mute your microphone to help everybody listen to the sessions in peace. Secondly, if you have any, once the sessions are covered by our master trainers. Third, we'll be taking a break at 8 p.m. for 5 minutes. Post that, we'll resume it. We are also planning to commence a 30 hours. So this will be a weekend program, Saturdays and Sundays. So we would like to share details about this course program towards the end of today's session. Last, in case there are certain technical issues, we'll definitely be sharing a recording of this session to all the attendees on our YouTube channel. So within next 24 hours, you will also get the recording on our YouTube channel. So thank you so much. And let's start the session. So I'm inviting my first expert, Dr. P. Rajagondan, to start the session. Welcome, sir.
Good evening, Sumit.
Yes, sir.
I want to share the screen. Can I do that?
Yes, sir. Yes, sir.
There's some echo coming, I don't know. Post disabled.
Just a moment, sir. Just a moment.
You enable it for me also.
Yes, sir, I'll do that. Sir, I've done it.
Done it?
Yes.
Okay, let me. Got it?
Yes, sir. It's visible now.
So can I start? Go.
Yes, sir. Please go ahead, sir.
Good evening, participants.
Good evening.
My name is Raja Gaundan. I think I've been already introduced. I worked in the railways. Now I have completed more or less now 50 years in the safety critical system in railways. That is the railway signaling. During this 50 years, I have been fortunate enough to go through 5 generations of safety critical systems, starting from the rudimentary systems, then the mechanical systems, then electromechanical systems, the electrical systems, and finally the electronic and software-based systems. So I just want to talk to you today about it. Is suddenly after railways have been working for 150 plus years, and we never topic has come, and everybody starts talking about the standards, functional safety, compliance to standards, etc., etc. So we will see an introduction to functional safety and why is it gaining importance these days. These are the overview on this lecture going to be for the next 20-30 minutes. So first we will see what is this functional safety. So what are the examples of functional safety systems in the railways? And then as I told you, why functional safety is important in railways now? Why was not important all these years? Then what are the terminology used in functional safety? This will enable you to go through my colleagues later because they will be using these terminologies. And how is the safety specified in railways? Or how do we specify the functional safety in railways? And finally, what are the functional safety standards which has to be complied with? It says functional safety is a part of overall safety. So that means the overall safety has got something else also in addition to functional safety. So what are those? Those are what we call intrinsic or technical safety and contextual safety. So a system has got 3 safety things. One is the technical or intrinsic safety, functional safety, and contextual safety. So we will see shortly what are these 3 safety systems are. But our focus is going to be functional safety. So functional safety is a part of the overall safety of a system or a piece of equipment that depends on automatic protection. So the safety of the system or the equipment depends on a subsystem which does the applicable to such a system. Only applicable to those systems which have an automatic protection. Now, once you have an automatic protection in place, this automatic protection system have to respond to the inputs correctly. And when it fails, after all, anything will fail. So when it fails, the failure response should be predictable. I should know in what mode, how it is going to fail. For example, if there is a failure, the system will switch off, shut down everything. That is one way of failing. So, but it should fail in a predictable manner. So the errors can be human errors, hardware failures, software failures, environmental stress, anything, over voltage, under voltage, over temperature, anything. But a failure comes, it should fail in a predictable manner. Number one, it should respond to the inputs correctly when it is working. And if there is a failure in it, which any system will have, it should fail in a predictable manner. Now, these 2 inputs, these 2 requirements of the functional safety system, that is function properly and fail in a predictable manner. The safety standards are designed, which my colleagues are going to talk, are designed to ensure that this happens. The standards are nothing but these 2 things. They ensure that if you follow the standard, these 2 things will happen. What does the functional safety system do? First of all, it identifies potentially dangerous conditions. What is in the environment or in the system? What are the dangerous conditions? It identifies. which will lead to an accident. Then it enables a corrective or preventive action. It does two actions, either possibility. One is corrective action or a preventive action to avoid or to reduce the impact of the accident. This is the sole purpose of the system, impact. I've given a simple example here. So there are many examples can be quoted. Here you've got a fuel storage tank on the left here. So the fuel is stored. I must prevent the overflow from the tank. I must prevent the overflow from the tank. So I keep a sensor, then I keep a control room. There is an operator, and there is a motor which pumps the fuel inside, or there is a. But as you know, human beings, the unsafe side failure possibilities are very high. So he may just forget, he may not be able to see it properly, or he may be attentive elsewhere. So this fuel will go overflow. So how do I prevent this? So I need an automatic protection system. How do I do that? An automatic protection system, which again has got a sensor and a controller here, electronic controller, which operates the valve, means it closes the valve or it switches off the motor. It does both the things. So if the level reaches the sensor in the red color, then it switches off, independent of the man's action. It's presumed that the man will act. Suppose he doesn't act, that the sensor will detect the fluid level and switches off the. So this is a functional safety system. The color in the red. So it has a sensor, it has a controller. So these are the components of a functional safety system: input, processing, and output. So this is the any automatic protection system will have this. So this is a simple example of a functional safety system. Functional safety system in the railways. You all must have seen the level crossing gates. Level crossing gates where the road crosses the railway line. Now, if I have to prevent an accident in the level crossing gate, I have got the simplest option which comes to my mind is an intrinsic safety system, which is on the left-hand side. So I put an underpass. I technically design it with a good load bearing capacity, etc., etc. So underpass. So this is absolutely safe. Absolutely safe. It is an intrinsic safety system or a technical safety system. For example, in a motor, you have got insulators which prevents shock when you touch the body of the motor. That is an intrinsic safety system. I put a meter, an ammeter, a current sensor, and use the current sensor to switch off the motor when the current exceeds a certain limit. And this is a functional safety system. While the insulator is an intrinsic or technical safety, this loop which I am providing, sensing the overcurrent and switching. What is a functional safety system? I can put the barriers here in the yellow line here. There are the barriers. I can sense the presence of a current of a train, let us say on the left-hand side, 1 kilometer away. Once I sense a train is coming, I can close the barrier. I can ring the alarm bell. I can switch on the flashing lights for the road user. Now, this is a cheaper system. Now, this is a functional safety system. So what does it do? It detects the approach of a train and processes it, and then switches on closes the risk to an acceptable level. I cannot eliminate here. The risk is totally eliminated on the left-hand side. In the intrinsic safety system, the risk is totally eliminated. Whereas here, I can reduce the system risk to an acceptable level. We will see what is the risk acceptance level in a few slides later. But the cost can be much lower. I can do this. Now, this is an ideal example of a functional safety system. The alarm will not come, nor the barrier will operate. So it will fail on the unsafe side. So there will be going to be a collision. So what do you do? I have to do a design mechanism to prevent this dangerous condition. So one way of doing it is attach a self-diagnostic circuit to the sensor that automatically lowers the barrier if the sensor breaks down. This is one way. There are many ways of doing it. This one way. This is called the fail-safe way. The other method is I can put 2 sensors or 3 sensors so that all of them failing at the same time is very, very rare. So these are some of the ways in which I can make the system more safe or reduce the risk. The second example of the functional safety in the railways is those who are involved in railway profession, you will know there is a thing called interlocking, which controls the logics of all the signals, points, etc. on the thing. This is a functional safety device. And there is a thing called automatic train protection in the train. In the train, there is a thing called automatic train protection. That means the train overspeeds, where it's supposed to stop at a particular place, and it is not going according to that speed profile, then the system will apply emergency brake and bring it to a stop. This is another functional safety application in the railways. These are the two popular functional safety application. There's one more is there. One more I can quote is the door. The door in the train, like in the metro doors, when it is closed, only the train can start moving. And while it is unmoved, the door cannot be opened. So these two are interlinked. So this is another functional safety device. There are many applications, many examples I can quote, but these are the popular ones. Now let us talk briefly on the interlocking. Now what does it do? You take a station here. The station is drawn here. There are two lines. One train is standing on one line. Another train is coming to a station. Now I have two options. I can give to this station master to operate all these points and signals and move trains from this end to this end. Now, for example, he's supposed to admit another train onto this because it will collide. So he can only take it on the free line. So this, he should know, he should do this correctly. Suppose he fails to touch to the about 10 to the power of 3, 1 in 10 to the power of 3, which is very poor. So if he fails, there will be a collision. So you have to operate 100 trains. So it's going to be difficult and you are likely to make a mistake. So how do I avoid that? So again, the station master operates from this equipment. Then I introduce in between an equipment called interlocking equipment. This takes care of all the logic that if there is a train in a line, the next train cannot be admitted. If the one signal is taken off and the opposing signal cannot be taken off. So you can devise a lot of rules and built into the interlocking device. And so that the whole operation, irrespective of what the man sitting on the panel does, interlocking system will only confine to the logic what is permitted. Not permitted logic, it will not allow. So this is another functional safety device in the railways. Now, we have seen what is functional safety. It is an automatic system and it should function properly. Number two, if it fails, it should fail. We're going to see why this functional safety has become important now at this time of why at this time? Why not this started, the whole thing started in the 1990s. 1990s only. So before that also railways ran, for example, were invented also. So why was it not done all these days? After we have been running it safely, then how did we do that? Now the older technologies, they possess certain characteristics, which is amenable to certain things, which takes care of safety. One is, the technology is, if equipment is visible for testing, I'm going to show an example. The example, the visible for testing, I can test it. I can visibly see it and test it. There's a limited combinations. I'll tell you what it is. Example is mechanical interlocking, electrical interlocking. These are visible and the combinations are limited. So I can test it, foolproof, 100%, and then be sure that yes, everything is fine. Now take this example for a simple relay circuit. I've provided a very, very simple relay circuit. There is a relay A, B, C, D, E, 5 relays. They are connected in a particular fashion. Don't worry about how they are connected. Why are they connected like this? If this combination is correct, then another relay XYZ will pick up. XYZ will pick up. Now, how do I test this? First, I should wire it. The installation time, I will connect first supply to the A relay. Then the contact of the A relay output will go to the B relay. B relay output, I will connect it to this relay. As shown in the circuit, I will wire it. After wiring done, I will test it. A to B, B to C, C to D, the wires are connected or not. Is there any other external wire is there or not? I will check it because there you can see with your eye whether it is there or not. Then I test it. I give supply, I switch off A and B. If this will not work, I'll switch off only A, it will not work. I'll switch off A and B and switch off D, it will not work. So all combinations required for XYZ to work. So once I do this, then my safety is 100% assured. I can define the wire insulation characteristic, the wired correctly or not, I can test it. I can do a functional test. Then by all these methods, I can ensure that what has been given to me, I can test it 100% and assure the safety. Now, all these procedures, what I have told you, these are called the code of practice. So we have been following what is called code of practice. Because code of practice, you can physically see things and write code of practice. So there was no need for functional safety. So I can test the safety and give it. Now, what happened later? The new technologies which have come, these are software-based, complex, and the testing is a large combinations are not possible. Now, in the previous one, we see that the testing is a few combinations. Maximum, I can have maybe 30, 40 relays in a circuit. So I can test all those things. Now, what happens when you go to the software? Now, let us look at it. Now, I've taken a simple yard, typical yard of the railways. See, what is the color, what I have seen is the signals. Then you can see there are certain cross black marks and written there 13P, TMT, TLT. These are what they call the track circuits, which detects the train and tells the operating panel that the portion is occupied or not. Then so these are some of the signaling gears in the station. Now, in a station like this, there are about 12 points, 25 track circuits, 15 signals, and some other gears. So total in all, 55 field equipment are there. Now, in this 55 field equipment, each of them are capable of a binary state. They don't take any other state. Either the track circuit is picked up or dropped. The point is normal or reverse. The signal is on or off. So they are all only binary states. That means when there are 55 functions, I will have 2. Now, all these days, why these 2 to the power 55 combinations were not tested? They were not tested because a particular function, what combination I need, and they're exclusive combinations. I can physically see these combinations, wire and see these combinations. So I can do those combinations and do the interlocking function. But when it comes to software, what do I do? Now, this can be converted into a Boolean equation. Yeah, you can convert, you can see this in the Boolean equation, A and B, and this loop, I can put, this is C bar because it is a back contact, C bar and D, and this is in parallel. So OR gate, RE, bracket close. Then if this Boolean logic takes place, I pick up XYZ. Now this is the problem. When I do this in software, I do A assumes 1 or 0, B assumes 1 or 0, C assumes 1 or 0, D assumes 1 or 0, so also E. Now only in this particular combination, XYZ should pick up. How do I know? Here I have wired, I know I can test it. How do I know in a software, there is no other combination will pick up XYZ? Definitely this will pick up, but I have to also ensure that no other combination has to pick up. That means I have to test all the 255 combinations, out of which one combination only will work. The balance all should not work. That is humanly impossible to do it. 2 to the power 55 is too large a number. You can't test it. So now, because of this is not possible to do, all tests are not possible to do, the standards have stipulated how to go about doing this software preparation, mainly. How to go about identifying the hazards. How to go about designing the functional safety functions to carry out the functional safety. Because of this complexity and problems, the functional safety has become important with the invention of the software-based systems for automatic train protection, or train control, or interlocking, or door control. Wherever there is a software and hardware combined, since it becomes an invisible and the combinations become too much, to test, and testing is not possible, unlike the other one. So the standards have been evolved, how to go ahead with how to ensure that a good safety is assured. Now, next we are going to see, now we have seen why functional safety has become of late so important in the hardware and software based systems. Now, what are the terminologies in the functional safety? So these are the terminologies in functional safety. One is hazard, harm, risk, safety, and RAC is risk acceptance criteria. Harm, risk, safety, and finally functional safety, because safety has got, I said, intrinsic safety, contextual safety, and functional safety. Contextual safety is what you do during the operation. Certain things you are not supposed to do. Do this first, do this second. So these are contextual safety procedures, which can lead to a harm. For example, you walk on the road or you walk in your house, there is an oil spill in a room somewhere. So this is a hazard. The presence of oil there is a hazard, but it does not call and harm yourself. So this is a hazard is an event. And how is hazard expressed? Hazard is expressed in events per hour or events per year. A hazard may cause an accident, may not cause an accident. It depends on how it evolves into, how it progresses into an accident. So hazard is events per hour or events per year. And hazard will result in harm. Hazard will result in harm. Now, how is harm expressed? It can be a catastrophic, meaning multiple fatalities, huge amount of deaths. In collision, two trains they collide, large number of deaths. It is a catastrophic accident. It can be a critical accident. It is a major injuries, minor injuries. Now, these are all terms and qualities of the severity which are in the standard 50126. So they're categorized. How do I do this? How do I categorize the severity of the accident? So harm is expressed in severity, and severity categories are this. The next is the risk. The risk is the probability of, it's a product of two things. What is the probability of the harm, and what is the multiplied by severity of the harm. Severity is said there are 4 or 5 categories. Probability of harm, you can always find out how the event hazard occurs by an FTA, the fault tree analysis of the system. There are methods which briefly my colleagues will cover it. You can probability of the harm you can find out, multiplied by severity will give you the risk. Now, if you see the unit of this is fatalities per event, which is the severity. So fatalities per hour is the unit of risk normally. Fatalities per hour is the unit of risk. Now, risk, if you do the risk analysis, they will tell you maybe later or in the course it will be covered. The risk can be an individual risk or collective risk. Now, the standards give the risk criteria for individual risk, not for collective risk. So you have to map collective risk to individual risk. So these procedures we'll see in the course. The individual risk can be expressed such as fatalities per passenger kilometer, which is used in railways. Fatalities, number of deaths per passenger kilometer. How much is that? It is an individual risk. How many fatalities occurred? That is a collective risk. Now, safety is freedom from unacceptable risk. So that means what risk is acceptable is okay, I am safe. If I accept a criteria, risk acceptance criteria, this many fatalities per passenger kilometer, if I set a norm, this is acceptable, then my system is safe. Now, for example, in the railways, we use fatalities per 10 to the power 8 passenger kilometer, person kilometer as the criteria, or fatalities per 10 to the power 8 hours is standard used is about 2. And if you use the person kilometer, it is 0.04. Now, in the course, which will, in the ensuing course, we are going to cover all this calculation of risk acceptance criteria. How do you convert from the collective also will be seen at that time. I'm not going to go into these. This is just to give you flower of these terms used. And functional safety, we have already seen what is functional safety. Now, how is safety specified in railways? We already seen that there is a risk acceptance criteria in terms of fatalities per passenger kilometer or fatalities per passenger hour. The example is fatalities per 10 to the power 8 passenger kilometer is 0.04 or fatalities per 10 to the power 8 hours is 2. Other ways of specifying as per 50126 is mean time between hazardous failures. That means mean time between such failures which will lead to a hazardous situation. All safety is in terms of the individual. Ultimately, the system industry, these are all derived from 61508, which is the umbrella standard. There are similar standards for other industries, which are again derived from this umbrella standard 61508. Now my colleagues are going to briefly cover what are mentioned in the standards, how to make the system functional, the functional safety, how to achieve or how to make the system work properly. Work properly means what? It should respond to the input signals properly, and when it fails to respond to input systems, it should fail in a predictable manner. These two things, primarily, the standards will make sure these two things are achieved. To achieve this, to understand this course of these standards, certain terminologies were required. I've just briefly introduced to the terminologies, and we will cover these terminologies, especially risk acceptance criteria, risk matrix, etc., in the 40-hour course. Thank you. I have covered. If any brief, just 2 minutes, if anything somebody wants to ask, we can discuss. Otherwise, take this lecture forward by my colleague, Mr. Surendranath.
Thank you, sir. Thank you so much, sir. So I would like to welcome.
So I am going to stop sharing.
Yes, sir.
Yeah, I have stopped. Suren, you can take over.
Sir. Sumit, confirm. Can you see the screen?
Yes, sir. That's visible.
Okay. So thank Dr. Gaundan. Thank you. That was a very peaceful introduction to a very complex subject called function safety. So my part here, next half an hour, I'll try to spend some time on giving you insight into standards. Half an hour is too small a time to talk about a very big subject called standards here, but I'll try and do my best. So I've spent 29 years in IT, 18 years in railway signaling product development. So I think almost all of the systems and products that go into what is called railway signaling. My main interest is safety critical product design development. So that's what I do day in and day out. Currently, I am driving an initiative for developing train collision avoidance system and electronic interlocking system in a company called Quadrant. So that's what I am. So introduction to SENELEC standards and list of standards. So whatever function safety that Dr. Gaundan had spoken about is in the context of railway signaling only. When I say railway signaling, it also includes rolling stock. That is a lot of software that goes on the coaches, train sets. It could be door opening, or it could be climate control, and so on and so forth. There are a whole lot of things. It is fully filled with software. Perspective of standards as to what exactly the standards contain and why do we need standards at all. So SENELEC is basically a European committee, largely driven by 3 companies, Siemens, Alstom, and Thales. These 3 put together contribute to development and evolution of these standards. And it has now become a de facto standard across the world. Of course, there are standards in America which are slightly different from SENELEC, but in a larger functional safety sense, both of them are very similar. So why do we need these standards? New standards, because it is absolutely mandatory now to see compliance. For any software-based system that is bound to have an impact on safety must be certified for its compliance with these standards. So you have no choice, especially those functions that are related to safety. Not every function that goes on a train. Only those which are expected to be safe or designed to be safe has to necessarily be compliant with these standards. There are 4 levels of safety. Again, it's a subjective term. So there are different levels of safety. Some are SIL 0, we call it safety integrity level. That is how we measure safety. And that's the lowest. And safety integrity level 4 is the highest. What does the safety integrity level actually mean? It means that there is certain degree of assurance. That's what Dr. Gondal also said. There is certain assurance that we have to provide as a designer and as a developer to make sure that the systems behave in a predictable manner. How do I do that? I do that by following the standards at an architectural level, or at a design level, or an implementation level, or at a testing stage. At every stage, every phase, I follow the standards to make sure the probability of making an error, a probability of making a judgmental error, probability of making a design error is either minimized or, if possible, eliminated. So standards essentially give you a very strong framework, which if you follow, will give you certain degree of assurance. That is what this SIL 4 or SIL 0 means. We have 1, 2, 3 also in between them. The probability of making a system failing is extremely low, extremely low. And also, another assurance is that the soft system has SIL 4. SIL 4 can be applied to hardware, it can be applied to software, or it can be applied to system. So it's a way how the user demands or how the requirement is, the SIL categorization is done. What is essentially standards? Standards are essentially a set of, I would say, a set of rules, set of procedures, list of techniques which are proven, so on and so forth, and list of documents that we need to produce as evidence that you have actually designed and developed the software and hardware in such a way that the safety of the system can be demonstrated with evidence. Evidence is essentially a document. Essentially, it boils down to a document in the form of a life cycle detail, or it can be a test report. These are the 2 types of document that eventually come in as a evidence. So what are the evidences that we need to produce? What are the documents that we need to produce as a part of driven development also is part of the standards. Let's step in and see what are the main standards that we talk about. Largely, these are the standards that we come across. I've been in this for almost 18 years. So day in and day out, these are the standards that we talk about. 121, 124, 126. All of you can read this. Essentially, I have tried to put what exactly the standards stand for. EMI compatibility is all about designing the hardware-based systems in such a way that it has electromagnetic influences are very high when you are talking about a locomotive, or when you're talking about any installation that is very close to a high voltage electrical substations and so on and so forth. So EMI compatibility is very, very essential, and 121 standard actually details all that is needed to be considered at a design stage. So how to ensure that your hardware is insulated enough so that the external factors do not have any impact on safety of your system. Similarly, 1 to 4 is about insulation coordination. Again, pertains largely to hardware designs. 1 to 6 is a major standard. It talks about RAMs. RAMs is reliability, availability, maintainability, and safety. So even though we talk about safety most of the times, inherently safety drives the other 3 factors: reliability, availability, and maintainability. So it's not enough if I say the system is safe, but it should also be available. So I can simply put a lock and key on a panel in a station and say the system is safe, but that's not safety. At the same time, it must offer maintainability. Something goes wrong, the system must continue to be safe, but should be maintainable. That means I must be able to plug in and plug out. And so how to achieve that? 1 to 6 standard explains in detail what are the procedures we need to follow, what are the documents you need to generate, what are the techniques you need to follow, so on and so forth, to ensure, and what are the target values that you have to achieve on reliability, availability, and maintainability. All the 4 of them are quantified for use. Maintainability is the amount of time it takes to repair a system or maintain a system. Safety is quantified as a targeted tolerable hazard ratio, THR. That means how many hazards can the system tolerate in a given span of time. It could be 100 years, 50 years, or one error in 50 years, one error in 60 years, and so on and so forth. So this is what the standards talk about. 159 is another important. 128 is very important. As Dr. Gordon said, all software-based systems essentially go through what is called the rigor of 128. 128 is totally dedicated to train control software. So compliance to 128 is absolutely essential for any software-based systems. 129 talks about signaling system specifically. 159 is about communication. So in the course, when you undergo the course, if at all, you will have a reasonable exposure to what 151 talks about closed communication. And 155 is all about the measures that you have to take to ensure that the systems don't fail when they are put on a rolling stock. For example, locomotive. If you have to design some system or a subsystem that works or designed to work on a locomotive, it has to tolerate to large extent some temperature range, wide temperature range, but more importantly, the shock and vibration that can impact a system on locomotive is very high, especially at high speeds. You have diesel locomotives, electrical locomotives, they generate lots of vibrations and shocks. So to be able to tolerate such kind of heavy duty shocks and vibrations, you need to design your complete hardware and mechanical casing, etc., in such a way that is tolerant to all these known types of disturbances. So 155 provides quite a few, I would say, very exhaustive set of guidelines and rules that you need to follow to ensure that the systems work safely and reliably on a when they are installed on a locomotive. So this is where perspective on standards. But what is it within the standards that we need to know, and what is that you'll get a feel of in the course? So before you get to the standards, you must understand what is a life cycle. A life cycle means from the day you conceive or conceptualize a product or a system for development till the time it is decommissioned out of the application, decommissioned from the application, that entire time period is called life cycle. It is not enough if you design a system to be safe for the first 2 months or 3 months. No, it has to be continuously safe till the time you decommission, and then you have to put it for use, and then you have to operate it, maintain it, and then eventually one day technology will become obsolete or application will become obsolete. So you might decide to decommission it. Even defining the decommissioning method is part of a life cycle. Just remember that. To make life easy, to understand standards better, it is always easier to divide and conquer. So how do you divide? Hardware, software, safety, documentation, data, test. If you understand the 6 building blocks for a system life cycle, so all the standards can be aligned. So what are the hardware related standards that I need to know if I have to develop a Salesforce system? That's what you'll get to know when you undergo the course. Similarly, what are the software related challenges that I will face, and what is the support that I'll get for software development from the requirement stage to the deployment stage. All the guidelines and procedures I need to follow is part of software lifecycle. And software is not just about one-time development. It undergoes continuous change. During its entire operation, a lifetime of a system, it might go multiple changes. So you should also consider what are the changes that are likely to come even after you install the system and commission the system. So software lifecycle is about following the standards to make sure that the software developed, installed, and upgraded also are part of the standard methodologies. Safety, as Dr. Gordon said, safety is simply freedom from hazards. He would use the word risk, but so entire methodologies are oriented in such a way that we try to continuously seek freedom from hazards. That means it's a process of continuously discovering what are the hazards that are possible when the system goes into operation, and then make sure that every such potential hazard is identified, is recorded, analyzed, and then adequately mitigated. What do I mean by mitigation? If you assume that hazard is a context that might likely to happen, if at all that happens in the real world, how will your system tolerate? How will the system first of all detect that hazard is likely to, and then to be able to tolerate that hazard and then mitigate the hazard into a acceptable safe state. The safe states might vary from context to context. So acceptable safe state, for example, train is running at 80 kmph or 100 kmph. Applying emergency brake is an acceptable safe state. Is it desirable? Not desirable, but in that context, it is absolutely acceptable. And then comes documentation. So anyone who is interested in standards must understand that there is no other choice but to document. Every notion has to be documented in absolute detail, because this is what will constitute the evidence of safety. Then data. Most often we get lost between hardware and software, but the more critical part of the systems that are evolving is centered around what is called data. What is data? As Dr. Gordon said, the signaling plan, the interlocking plan, the table of control. These are the keywords that you come across when you are in a railway application. All these constitute what is called data. Data is essentially a set of field objects and the way they are interconnected and the way they are expected to perform when somebody is in a operation mode. That is what is testing. The lot of care needs to be taken. If you are trying to develop a SIL4 system, you need to have execute extreme care in the way you capture, in the way you store, in the way you transform, and the way you actually use it and store it. So data itself is one separate life cycle in these safety critical systems. So in the course, you will learn more about how the data has to be handled with care so that they qualify to be safe. Testing, there are many levels of testing, right from software development. Multiple stages happen within the software development phases. Apart from that, there is an integration testing, there is a functional testing, there is an acceptance testing, environmental testing, climatic testing, so on and so forth. Detected before it is installed. That's the intent. The standards talk very elaborately about testing as to what are the necessary testings need to be done to ensure that the system is safe for use. Takes really that's really a hard way to do. So I'm just trying to give you a summary of my expertise in this in the form of one slide. I'll try to spend a few minutes on each of them. These are the concepts that you must know if you want to really appreciate, because once you open the standards, these are the points where you are likely to get stuck. So let me spend some time on it. Redundancy and diversity. This is intrinsic, either redundancy or diversity or both. Redundancy means A upon A. That means you have one box and that's working, and there's a likelihood of this system failing. So what do? You put a second box. So A plus A, two systems you put, and then say if one fails, other will take over, and vice versa. That is called redundancy. This is one of the measure. This is not a safety measure, but it's a availability and reliability measure. Then comes diversity. If I put A on A, there is a remote chance that the same condition which caused A failure can also cause the second A also to fail. To remove that remote possibility of two of the systems failing at the same time because of an unexpected error, we opt for what is called diversity. Diversity is A upon B. That means A and B differ in at least one way. That is called diversity. It not necessarily has to be totally a different system. Between A and B, the difference could be hardware, it could be software, it could be the way data is managed, it could be the interfaces or external data sensors are managed. There could be any difference. It could be even simplest form of software compilation using two different compilers also is accepted as diversity. So this is to eliminate one remote possibility of both of them failing at the same condition. That is diversity. Normally in safety critical systems, we use diversity. Verification and validation. Verification is a job of ensuring that my software is complete, and validation is a job of ensuring that my correctness. So to do this, there are a lot many procedures that standards provide for, and once you understand these two processes, it is the expected requirements.
Surendra sir.
Traceability, sir.
So there is
Sumit.
some disturbance coming from your microphone, sir. As you're speaking, we're facing some, hearing some disturbances.
Okay, is it better now?
So this is better. This is better.
Okay, great.
Probably a little bit distance between the microphone would be.
Okay, fine. I'm sorry about that. Traceability is the process of ensuring from the time you begin to develop a system to the time you install a system or even commission a system, that all the requirements are actually met, looking forward and looking backward. That means from the day I started off, I converted my requirements to architecture and then to design and then to implement and then test and so on and so forth. And also look back from the system that I tested, I'll trace back to original requirements and see if any unnecessary muck has entered my system without my knowledge. So traceability ensures completeness in some sense. Safety assurance, I think we talked about enough. MTTR is time to repair. So given the fact that these critical systems are required to be highly available, it is important to make sure the time taken to repair is very, very minimal. Normally minutes and hours, no more than that. MTBF, I told you, is mean time between failures. That is the factor that measures reliability of a system. And you will learn a lot when you study these standards. I told you about THR is a tolerable hazard rate. Correctness, completeness, I think a SIL is something I covered. MISRA standards is a guiding force for those who are in software development. Any safety critical system, SIL 0 or SIL 4, must adhere to what is called MISRA standards, which is Motor Industries Software Reusability Association. So there is a guidelines that Automotive Group has brought about, and this has now become a de facto standard for railways also. So all the software that you write must essentially comply to these MISRA standards. These are nothing but a set of 140 plus rules which you have to follow if you're writing a piece of code. And there are tools that will automatically check whether you have followed MISRA rules or not. And once you do that, it is a reasonable degree of assurance that the software is safe for use. I told about RAMs. Process compliance is about making sure that not only you develop the software as per the guidelines, but you have to necessarily follow the process. That means you have to first architect the system and then design and then perform the design review and then perform the design analysis. And then on paper, you have to prove that your system is intrinsically safe. So process compliance is all about a set of methods and procedures that you have to follow to ensure that the software that you are going to develop or hardware you're going to develop is essentially in line with what standards expect you to do. Good and bad designs. Some bad designs can pass through the standards. So essential that you know, designs are essentially a conscious trade-off for and against. That's what a design is. So when you go through these standards, you must appreciate that what a good design is and what a bad design is. So more about it when you undergo the course. This itself can be a 1 hour session. Architecture is how you define the boundaries of the system and what is within the system and what is beyond the system. This is what one must understand before they step into standard. What kind of tools am I permitted to use? What kind of techniques am I permitted to use in each phase of the software development is what is covered in the standards in absolute detail. Risk analysis is what is in case a failure actually happens and if it turns out to be a hazard, what is the potential impact of such a hazard? Will it result in loss of property or will it result in loss of death, or in case if it is property, how critical it is going to be? Quantifying the impact of each such hazard in detail and coming to terms with it is called risk analysis, so that you decide whether finding ways and means of mitigating them or tolerating them within the system confines so that the system continues to be safe. And just in case it has to fail, it will fail on the right side and not the wrong side. That's what hazard management is. There are all the process compliances, standards compliances, design analysis, and a whole bunch of assurances saying that this system, which was developed for this purpose, indeed has followed the standards, indeed has followed the FIOs. And most of the standards 1 to 6, 1 to 8, 1 to 9 that we talked about are essentially a set of tables. So if you want to master the standards, the best thing is to take each table, rip it open, and analyze them, assimilate them, and then conquer them. So some challenges most of the times in standards, what this course will teach you is in many of these tables within these standards, we have many options to choose. So where will you get stuck? This is where you're likely to get stuck. What options to choose? What techniques are relevant to my scope of work? Product may be a SIL 0 product, a SIL 1 product, SIL 2 product, whatever. So what are the techniques that are best relevant to me? What makes sense to me? This is where you're likely to get stuck. And these are the few things that your course will teach you. And cost implications of each of the choices. Each of the choices you take, if you take modeling as one of the choices you make for software development, it could result in very exorbitant tools that we have to buy. Dealing with recommended, highly recommended, and mandatory. There are 2-3 types of categorization of every rule. So how to, which one to choose discreetly, recommended or highly recommended or mandatory. Mandatory, you don't have a choice. In highly recommended, which one to absorb, which one to ignore. It's a very conscious choice that you have to make. That's what the course will teach about. And justification of each of the choices you make and interpretation of the clauses that you want to adopt is what the course will teach you. So the best way to conquer the standards is not to get scared by it, but to understand what are the people related. Divide this into 3 parts. Then it's very easy. This is the way I learned it. I go and look for all people related. That means, how do I organize the people so that these standards can be understood, assimilated, and implemented across a software development lifecycle. Similarly, process. What are the processes? So what we do generally is to identify one person for each of these tasks: people, process, and product. One person will champion the cause of people. That means all the people organization, whether it is skill wise or orientation wise, alignment wise, responsibility wise, how to align everybody in such a way that it is in tune with what standards expect. Other champion for process will actually try to continuously define and refine the processes that make up what is called standards compliance. And of course, the product. So interweaving between people and process is actually the product requirements, which are not part of the standards. So how to align the product requirements and the standards is what a product champion does. By doing this, you'll conquer the otherwise a bulky subject called standards. These are more details. This presentation is more meant for detail. All of you can go through. I just try to list down a summary of what the standards look like. So this is what the standards will. I have addressed most of the keywords. Thank you. And unless you have some questions to ask.
Sir, I think thank you so much for this session, sir. So there are some questions which people have asked. Can I take them up right now?
Yeah, please.
Okay. So, sir, I'll start from what is, sir, is there any specific standard for DC traction system?
DC traction systems.
Yes.
I mean, whatever, if you're talking about design of DC traction systems, it is nothing but one another electrical powerhouse. So if you are developing software for it, then you have to follow 128. There's no standard specifically for DC traction that way, but whatever hardware and software that contain, they must follow some level of SIL standards. And also depends on the user expectation, what SIL category does.
Okay, right. Sir, is functional safety applicable for every EI system?
Yes.
Okay.
100%.
And does the life cycle of the project has any relevance to GRIP in India?
I'm sorry, I'm not aware of this GRIP. Dr. Gaundan, what is this GRIP? Dr. Ajit? Maybe they are muted. Samir?
Okay. Let me just unmute them, sir.
Yeah.
So, Dr. Ajit, I'm not able to track you from the list of the participants. Could you just?
He's at least his name is there on the screen.
Okay, sir. I've got it.
Yeah.
Right. Thank you. Sir,
hello.
GRIP. Is there anything called GRIP in this context of safety and railway signaling?
GRIP? No, I don't have any such a word across.
Or whoever is governance of rail investment project.
Governance of rail investment project.
We're sorry, Diksha, we are not too familiar with this, but
it is the safety approval. What is some technology tool? What is this? Maybe some context. Then I think we can take it.
Allow Diksha to ask that question herself.
Okay, just a moment, sir. I'm just so Diksha, please ask your question.
Good evening, everyone. Sir, actually, I wanted to ask, you were actually talking about the project life cycle. And so I have read about the system that includes that railway investment. If Indian Railways also include such kind of process of, having some kind of, we know that there's a process, 1, 2, it's also, it's actually more of Australian and UK railways. They use have investment projects with the life cycle. So does Indian Railways include such kind of procedures in their projects?
Not explicitly so, to the extent that we have dealt with railways for so long, but possibly in the future this becomes a standard, Diksha.
Okay, because it does have the safety features in it. That's why I wanted to know that does it get involved in railways also?
As of now, there is no specific equivalent of GRIP or something like that in the Indian context, but certainly you can expect in the future as number of projects and complexities go up. Yes, it is required in the future.
Okay, thank you.
Yep.
Sir, I think we should give you co-host, sir. You may share your screen.
Okay. Thank you, everyone.
Thank you so much.
Hello, Sumit, I'm here. So yeah, I'm here. So I think if you have any questions regarding this safety analysis techniques and tools for the project life cycle, so basically in the project life cycle, and on the top of that there is safety life cycle from the hazard identification. First things is the system definition, then hazard identification, risk analysis. There are many techniques depending upon the project progress. If project is the concept phase and initial phase, we have certain techniques. If project is go to little maturity of design to design, maybe initial design, preliminary design, we have some techniques. So on, as progressively we can apply many kind of techniques specific to those life cycle, and somehow these safety life cycle are somehow intertwined with the project life cycle and all the hazards, and somehow we can record those things in some hazard. Then we try to record some kind of evidences, which is called safety case. And this evidence is given to the approval body, regulatory bodies, maybe sometimes ISA, sometimes Indian context, maybe some RDSO similar to that. And then only once they approve, then people get the permission of safety. So with respect to this, if anybody has any concern, any question, I'm here to answer this.
Sir, would you like?
Actually, I can directly take up the questions, no problem.
Okay. So, sir, there's a question from Mr. Jagdish. Is RAMS implemented in Indian Railways or only in Metro?
So, Indian Railway, when it comes to safety, the first of all, when RAMS implementation concept came, RAMS basically, so there is no earlier concept in the RAMS in the Indian Railway. Okay, we have a conventional safety approval method, and there is a CMRS, Chief Commissioner of Railway Safety, who comes and the last of during the commercial opening, and they will give some certificate. So Indian Railway, earlier traditional way, they assume that safety is covered through good engineering practice, because there are many good engineering practice as per member mechanical, member electrical, all those things. But formally, no, they don't have any kind of this kind of RAMS implementation in Indian Railway. But coming to the concept of this metro and different kind of technology, metro and monorail, high-speed rail. So these kind of contractor in these kind of projects from the multinational companies. So they have implemented RAMS, and so the concept of RAMS has been started in the Indian Railway. So metros and other new technologies are high-speed bullet train. They are using the RAMS implementation as per the Indian standards. But traditional Indian Railway, they have not implemented. Nevertheless, I have came across many senior officers and many other forums where they wanted to incorporate those things in the Indian Railway, because now Indian Railway is going to transform. Because many technologies like the electrifications are going to upgrade, signaling they are going to upgrade. So definitely they convinced that this RAMS implementation, definitely they are going to give good values in terms of life cycle cost, in terms of safety, in terms of goodwill as well, because they are comparing from the foreign lines. They have started RAMS implementation. For example, recently you might have heard the DFCC is kind of Indian Railway project, dedicated freight corridor, and they have formally introduced in their contract RAMS. They are following RAMS. Similarly, some of the other, I was there in some metro project, RRTS Meerut. So we are in the transition phase where Indian Railway is now also inclined to adopt these RAMS practices. So hope your question is answered here.
Sir, thank you, sir. So, sir, I have a question which I would like to ask. So, sir, what are the career opportunities available in the area of functional safety? So, my question is for all of you, all the three master trainers that we have today. Kaunden sir, Surendra sir, Ajit sir. So there are a lot of people who would like to know about the career point.
Because of construction safety, they may directly or indirectly impact the functional safety. Just to touch the subject, suppose you are making a platform, and platform construction is construction safety. So while making a platform, there is some gap between train, there is a gap or there is a height difference. So these kind of differences, this kind of errors done during the construction may impact the functional safety. But if you come to functional safety, that is a completely different. It is governed by the certain EN standards, EN 50126, 128, 129. So if you go to railway, functional safety is a complete, it is a mandatory requirement for all the railway projects. Not only signaling, all the electrical, electronics, and programming electronic systems. You are making SCADA design, you are making platform screen door, you are making signaling system, rolling stock, even some kinds of track monitoring system. Line, there is a concept of the functional safety in automotive, because automotive, there are driverless cab is coming, or some kind of other automotive systems are there. So functional safety is applicable to automotive, avionics, medical devices, oil and gas, nuclear power, everywhere. And the concept of functional safety is derived from the IEC 61508. IEC 6156 sector-specific standards has been derived, which serve the purpose of the specific industry. For example, you write some coding or some designing of avionics. You have to take the reference from IEC 615. Functional safety is a huge career because it's a different layers are there. You are designer, you are verifier, you are assessor. Suppose you want to endorse somebody design is for functional safety, you have to go to ISA. You are the verifier and validator, you have to do something. You are the implementer, you have to write a code or you have to write design. So there is ample opportunity because the criticality is so important and every government is approving this way. So this is my point. Anybody wants to add here, you can add, please. Sumit, I am done. Am I audible? I hope I'm audible.
Yes, sir. Yes, sir. So, sir, I'll move to the next question. So, what are the safety functional methodologies used in positive train control?
What are the
safety functional methodologies used in positive train control? That's the question, sir.
The question is not complete, I think. Who has asked? Can you give unmute so that I can understand which context he's asking?
Okay, Ramesh, just a moment. Let me just unmute you, Ramesh, so that you could ask your question. Please ask your question. I'm unmuting you, Ramesh.
Yeah, good evening, everyone.
Yes.
Thanks for giving me opportunity to ask this question. So basically, my question is, so what are the safety methodologies? Particularly IETMS we are working on, interoperability electronic train management system. So basically, I mean, what standard, what safety integrated level is applicable and what safety software methodologies are used for any functional?
Okay. So as I correctly understood, function for any system, either you are working positive control, ceiling system, or rolling stock. Okay. So what is the safety criticality? The first starting point is the safety requirement, and which is given by the your contract. Okay, this is the function, positive training control, and I want seal 2, seal 3, seal 4, and whatever. So it is not you to decide, and it is no standard decide. Suppose you are following certain, normally this kind of definitions given in the EN standard, EN 50 part 2. So you can note down EN 50126 part 2. So that function. So once you decided that my positive train control, automatic train control systems, or automatic train protection system, anything, it is the requirement is seal 3 or seal 4. Then depending upon the technology and software design. For hardware design, there are many tools and techniques mentioned in these standards, and you have to follow those things. Similarly, for software, you have to comply with EN 50128. How to develop a software complied with your seal level. So I'm assuming it is the positive train control seal 4. For seal 4, because of vital control unit, you have to do certain kind of software development and hardware. Moreover, these tools must be qualified to use in seal 4 environment. For example, let us say layman language. I'm developing safety implementation. Any tools I can use. I can use any software, Visual Basic and all the display units. But if you are developing any software for safety environment, so what programming language, what tool, even what operating system? You can't use Windows. You have to use tool, validation tool, operating system, hardware, software, everything should be qualified to produce those kind of hardware and software to develop the particular safety critical systems. Okay. So in single line, it is what is the seal requirement. It is not you, it is your client will tell my requirement is this. Requirement given by the client, and as a designer, implementer, we have to make sure to meet.
Thank you, sir. Sir, I'll take the next question. Mr. Hanuman would like you to kindly elaborate upon traceability for software-based railway systems.
So traceability, again, see, traceability means basically once you develop a software from requirement one-to-one mapping, that all the requirements with respect to your, I'm talking about software. The first of all, in software also, I assume that what your question belongs to software safety. Because railway software safety is more important. Okay. So first of all, there are 4 kind of seal in software. Seal 1, seal 2, seal 3, seal 4. Anything lower than seal 1, we call the basic integrity software. So for basic integrity, there is no stringent requirement. But for other, there is a stringent, some decision table, how to design architecture, 5 methods against every seal level. So if you go to standard 50128, which has been recently revised last year, 2020, there is a table. So once you develop all those things, ISA will requirement till implementation. You have done the right codes. So we have to develop a kind of compliance matrix that against evidence reference document. Yeah, this is my design document. We have used the formal method. This is my coding document. We use ADA language and all these things. This is my verification document. So this kind of traceability from requirement to implementation is required, and we can develop one compliance matrix table, a compliance document. And that document is assessed by the ISA to give you seal certificates. So this is the, in nutshell, I can tell you.
So is there any standard for cyber security?
Yes. So this is not cyber security. It is called the communication, basically. In railway environment, now you understand the railway environment, we are going to automate everything. In future, coming to the concept of 4G and 5G. Now, down the line, sometimes you can see many information on the cloud. From here, we can see our train movement, everything. So once communication is involved, somebody can disturb intensely to your things. So this is called the security in the railway environment, and that covers the cyber security and software security and communication security both. So Sumit, you can see if my question is my answer is creating another question, I'm here to clarify, because sometimes happen if you answer something, it may create confusion. It should not be it should not like that. So if my answer is creating another question, please
them up, and or if required, I'll also unmute you to ask your question directly. So so sir, I'll take some 5 minutes now to explain the 12th February, which is Saturday, and the classes will be held every Saturday and Sunday, 7 p.m. to 9 p.m. online. So now I think I've explained what are the career opportunities which are there in this particular industry. So all those who belong in this course program. On a particular note, railway engineers from any domain, civil, electrical, mechanical, signal and telecom, metro rail engineers, any engineer who's working in railway industry is look at our experts will take you deep down to these standards to functional safety, followed by a lot of case studies will be taken during the course of the course tenure, followed by a small project that we're planning this time. This is the first time we're planning a project understanding of the concepts covered in the class sessions. So that we're planning to launch in this. A lot of interaction will be there. A lot of you'll be also working on particular problems and case studies. So we are expecting a lot of learning on these areas. Going forward, as you've already met 3 of our faculties, Rajesh sir is expected to join shortly. He'll also be taking up a small session on today's webinar. 30 sessions. These sessions will be divided across our experts. So self-introduction, Raja Gondan sir would be taking it, 5012X, Dr. Ajit Pandey and Mr. Abdullah. Then Senelec 5012 into actually help you take a deep dive. Then there would be a small project on functional safety and followed by an online assessment. So when we talk about assessments, there will be a multiple choice based assessment that will be conducted at the end of the session. So you need to secure around 60% in the assessment to be eligible for a certificate. Definitely we'll be also, like we do for all our courses, session recordings shall be made available to the trainees through our LMS, and every day 7 p.m. to 9 p.m. And there are February 20,000 plus GST. Payment link is given in this registering in groups of 3 or more. So there will be a discounted price of 18,000 plus GST. If you are enrolling from your company, if there's a company or a group which is having 5 plus enrollments, so there's a further discounted price that we are offering on 5 plus enrollments. EMI options are also available. You may write to us and we'll be able to share the options available, and we'll be taking up the conversation one-to-one. Further, these are our WhatsApp and phone lines and our website. So you may contact us. If you have any questions, please let us know. We'll be presentation, and you would have actually noticed experience, knowledge from their experience. We'll share the payment link with you shortly. And if you have any other questions, Dr. Ajit Kumar, kindly elaborate on this.
How about automatic level crossing gates?
One product is very common known like the GCP, grade crossing predictor. Okay, will blink, then automatic train will go. This kind of, okay. So train is coming and sensor unable to sense the train speed and all this. Depending upon train speed, the warning. Sometimes he makes the light, then noise, and then finally he's down the signal. Okay, down the gate. So this kind of things. And sometimes what happens? Suppose train is coming, a train is not there, and sensor sense some other object, maybe some catalyst object, and do it. So what is the wrong side failure? What is right side failure? These all possibilities can be taken care during the design of this automatic level crossings. Okay.
I'll just add to that. RDSO has a spec on this particular product. It is called train actuated warning device. So So as soon as the train leaves the previous station, approaching the gate, information comes to the some other characteristics that are available to it. It will decide when to close the gate. So that kind of intelligence also exists.
Yes.
Sir, can you repeat the name of the project, please?
Train actuated warning device.
Thank you, sir. Thank you.
I'll take up some questions right now, sir, as Rajesh sir is yet to join. So, how EN standards for functional safety?
Okay. So, I'm not sure whether you have seen both the standard or not. Go to open IEC 62279, IEC 6278, and IEC 62484 standard IEC and control F EN 50128. They have mentioned in the cover page or after some introduction page. This standard is aligned with EN. Both are consistent. Even if your contract is mandated, you have to follow EN. It is the deemed to be accepted. There is no controversy at all. Okay. So both are completely aligned one-to-one. Even the number of sections, subsection, figure.
Subset of it was taken and then improved and enhanced to specific.
IC is not first. In the railway, EN is the first.
Correct.
Okay. So in India, I involved in the DFCC project. So when the contract had been written, so depends upon the who are the consultants. Most of the consultant in DFCC, I don't mind to name, that is the Orient consultant, Orient. Okay. So they are from the Japan, PMC. Most of the consultant like AECOM, Sista, they are from Europe. They are written, that's why both are same.
Does functional safety of railway operation depend on a user desire?
Yes.
Okay, so another question from Mr. Thompson. When we certify our products for safety, should we bother about reliability, maintainability, and availability?
Is the only thing. Safety means in its layman language. Suppose functional safety, your system has some function. So safety means what is the reliability of your function that is going to work. So reliability is inherent. Reliability we have to make sure. And many cell calculations function is a cell. What is the reliability of such function? Is a cell. The probability of failure is this much.
I wanted to ask another question. So I'm unmuting you, Raju. You can please ask your question. So we
have sir, how about automatic
what is the question?
I heard that it's some another company, Auxiliary Power Unit. Do I know any auxiliary power unit? Auxiliary power.
Suren sir, what is? Can you add here something? What is?
I could not comprehend the question. Please repeat the question. Can you?
I need explanation about auxiliary power unit, sir. It is used in diesel engines, I think.
Correct. So
what is the use of APU? Why it is installed?
Basically, power source will be one. Okay, it will generate certain amount of voltage and that will work on 110 volt DC or AC. So there are so many requirements on a locomotive which have different types of voltages and different types of current requirements.
Are there any other questions? I think I'm trying to reach out to Rajesh sir. Probably
we will try to address his points also.
No problem. If you have any questions, please go ahead, and you can raise your hands, and I'll unmute you to ask your questions directly. If you have any questions to ask, please go ahead.
Whatever secondary requirements are there, they all come under auxiliary power needs. I hope the answer is clear to them.
Please.
Yes, sir.
Oh,
yes,
please go ahead. Please go ahead.
Please.
We're very happy to hear you.
Thank you, sir. Thank you for giving me this opportunity. Actually, auxiliary power unit is a external separate unit provided in nose compartment of the locomotive for want of saving the fuel. The main purpose of this equipment is to provide the brake system brake system with compressor or expressor, whatever the equipment they are using, should be supplied with this compressor and this one. Actually, the main issue is the compressor works on engine. What they call engine RPM, means it is on the same shaft of the engine. So to run the to supply the only air compressed air, we have to run the engine continuously. Instead of that, we use a small compressor to supply the brake system. Instead of running entire locomotive, we can shut down the locomotive and we can supply the air pressure to the braking system. That is the only function. It can be supply some lighting equipment like dome light of the locomotive or compartment lights like that. Like that, it can be supplied. So there will be only for the purpose they are using auxiliary power unit. During this one, if we keep ideal, means the train is notch up for 10 minutes. After that, it will warn for 1 minute. It will give a warning that your main engine will be shut down within 1 minute. After lapse of a minute, the main engine will shut down and auxiliary power unit will crank again, and it will supply the air pressure as well as the lighting power supply. It will be, I think so, it is 110 volts, all like cab fan as well as the dome lights and that. All the small power will be supplied from the auxiliary power unit only, and it is the mainly purpose to maintain the brake supply. That is the main purpose. Thank you for giving the opportunity.
Thank you so much. Thank you so much. So I'll take the next question from Sridhar, who's asking how safety is applicable for application software.
Who is asking this question? They can elaborate a little more.
Sridhar.
Mr. Sridhar, please explain what's your doubt.
Sridhar, please unmute yourself and you can ask your question directly.
Hello, sir. Is that audible, sir?
Yeah.
Yeah, in my company, I'm working in signaling projects.
Okay.
So one of my colleagues, he's interested to participate in this trainings. So how it is applicable to me?
Okay. When it comes to data, basically, the user defines the data in a couple of formats like signal interlocking plan or table of control, relay circuit, and so on. Now, this is the paper input that you will get. What would you do? You would convert that into a digital format and then do multiple transformations before it is stored in some form that your software can read. In this process, you are capturing the data and subjecting that to many transformations. So how do I know that the data given by the user is the data that they have actually captured and without any loss of integrity? How do you ensure that? So that means for that we have a very well defined process for data management. So how to define, how to capture, how to store, and how to demonstrate that, and how to demonstrate that the data is not corrupted while it is being transformed from one form to another. So there are relevant standards, especially 128 has a specific chapter on this. So that tells you with all the tools, techniques, and methods to follow to make sure that you don't make any mistake when you deal with data.
Thank you, sir. Sir, I'll take up a question from Surendra.
Sir.
Is this course having any relevance or use in designing and installation of OHE traction? Will this be helpful?
Not really, but there's no harm in, for example, EMI, EMC. That relevance I see with respect to OHE installations, because there are certain protection measures you must provide in OHE installations. You can derive strength from the EMI standards 1-to-1 as applicable to OHE. Yes, it will be during this course, a lot of examples will be covered as to what kind of production measures are required at OHE and where are the standards they are derived from. Yes.
Thank you, sir. Sir, Arumugam is asking a question that what is the EN standard number track safety standards?
Sorry, track safety.
What is the EN number for track safety standards?
Oh, I'm not aware because I haven't dealt with track safety.
No, there is no track safety standard. Basically, there is a UIC. There is UIC standards and other standard. So for track design, okay, but EN 5019 is only standard who is ensuring the safety of all the systems. Okay, for track design standard is there for everywhere. For safety, if you come to safety, only EN 5019 is applicable, which will collect the evidence of safety has been taken in design. So on the top of every standard, on the top of every design standard, EN will going to endorse that you have designed system correctly. There is no track safety standard. Track design standard is there.
Okay, thank you, sir. Surendra is asking a question, sir. How this course will help an Indian railways working signal engineer with 5+ years of experience to attain employment in corporate or in foreign railway companies? I think
anybody who is good at standards, especially 126, 128, and 129, they are welcome to apply for a job today. Tomorrow morning, I'll issue an offer.
Thank you, sir. Batula is asking a question. Will station controller of metro rail industry can take this course for career growth? I think yes. You may elaborate.
Yeah, I think this is a good question. There are two ways you should look at standards. One, as a developer, as an OEM, original equipment manufacturer, you conceptualize, design, develop a system and offer it to the railway. That is one way. So you have a role to play while system is being designed. The other side of the story is, as a user, you accept a safety critical system. So if you are on the other side, you can equip yourself with these standards so that you are completely capable of accepting a safety critical system, number one, testing a safety critical system, number two, and contribute to evolution of tenders in such a way that they incorporate all the necessary safety features. So there are many ways you can contribute. If you are on this side, one level of activity. If you're on the user side, you have other level of activity. You can even design an acceptance test plan that will make sure that the system is being accepted is actually safe for use, because the OEMs will bother only up to installation and commissioning phase. After that comes operations. Operations belong to the railway. So if you're on the railway community side, what are the measures you must take to be able to document the reliability data, document the safety data, to be able to analyze that data? You need thorough knowledge of standards. So that's the way you should look at it.
Thank you, sir. So another question I'll take up from Surendra, sir, asking about, is there any plan to start a course exclusively on EMI, EMC and RAMS analysis? So I think
so I suggest you can also launch a course on EMI, EMC. Yep.
RAM analysis is different here. RAM analysis, we are not going detail here. RAM is different. See, in RAM analysis, reliability, availability, maintainability. So when we talk about the RAM in a simple way, RAM is for the performance. It means everything what system was supposed to do is RAM. And the things what system are not supposed to do is safety. Okay. So both approaches is different. In reliability analysis, every failure will be considered. In the safety, which is the probability of dangerous failure, which can create mishap, injuries, and all these things. So RAM is a different subject. There is a overlap in between. Both are, there is some intertwined. But as a standard also, we have different standards and different tools and technologies. Even the contract also, a RAM engineer is different, safety engineer is different. So better we have to do it separately, RAM.
So from Railway, on behalf of Railway Academy, we would be launching a course on EMI, EMC. Maybe in a month or two, we'll be planning a course on this as well. Now, my next question is, can a fresher apply for this course? Will it be helpful for him? A fresher engineer.
To me, I think it is not very much helpful, because see, we are using the many terms in railways and all systems, traction, OFTS, and signaling, to many keywords. I think it is the bandwidth will be more, so he gets some advantage, but not really that his all bandwidth shall be not absorbed as a fresher. This is my view.
Okay. Sir, next is, I think, based upon vendor target defined for train. Okay. Surendra Gowda. Okay. Surendra, let me just unmute you once more so that you can ask your question. Just a moment. Surendra. Okay, Surendra, please go ahead and ask your question. I've asked you to unmute.
Yes, sir. Good evening, sir. I'm Surendra. I'm working in railways in SSC, senior section engineer since last 5 years. Actually, I have asked the I got the answer up to some extent, but I actually want to switch from railways to corporate companies. So I need to explanation how is this course is going.
See, for you to enter, Surendra, for you to enter the corporate world, you must have formal knowledge. As a SSC, I think you have good exposure to the workings of the railways. You know how the installation works, you know how to troubleshoot and so on. But please understand, if you want to really contribute to product development in the corporate world, you must have formal knowledge. So formal knowledge is all about knowledge of standards. So that is what you will exactly get in this course.
Okay, I think we'll look at concluding our session here. So I would like to thank all our master trainers who've taken out their precious time to join us for this webinar. And I think that we have managed to explain the opportunities in functional safety to all of you. And we've also tried to do justice to your questions. So with this, I would like to invite you to be part of this course program and start learning and look at being part of this industry. So you are free to, please feel free to write to us or contact us on our WhatsApp number, and we'll be happy to take up your questions and queries, if any. Right? Thank you.
And Sumit, keep the forum open, and anyone who has left out or could not ask questions or we did not address them, they can email it to you. We can collectively send it to all of us. We'll try and answer them.
Yes, Raju has one last question, sir. He's been raising his hand, so I'm unmuting him to ask this one question. Raju, please go ahead. Raju.
Sir, what is the lifespan of?
Yeah. Yes, Raju, please go ahead.
You have to unmute him, I think.
Raju, okay. Please go ahead.
Sir, what is the lifespan of signal lamp and point?
Signal lamps. Now
Yes,
technologies are changing very fast. So incandescent to now LEDs. LEDs have a long shelf life, more than 10 years.
more than 10 years.
Yeah.
What points, sir?
Point machines need, of course, point machines are substantial. 10 to 15 years is lifelong, if provided they are maintained very well.
So it's for design life. You are talking about design life. Okay.
Design life, yeah.
Sir, thank you, sir.
Thank you, everyone. And I'm just pasting our YouTube channel links in the chat box. Please follow us on our YouTube, LinkedIn, and Facebook. We announce our courses and updates related to our courses on these pages, so that please join these pages to get these updates in real time. So thank you very much for your questions. Thank you. Yes, there would be certification for this PROS program from Railway Academy, which is an industry recognized. And okay. Thank you so much. Thank you so much, and have a great evening. Thank you.
Thank you, everyone.
Thank you, sir. Thank you, Ajit, sir. Thank you,
Ajit.
Thank you so much.
Thank you, everyone.
Bye, everyone.
Bye. Good night.